I know I'm the only thing keeping you between now and lunch, so I'm going to take you through a marathon because I have 143 slides. I know I have 50 minutes. I promise I won't speak to each one of them. So it'll feel like you ran 400 meters by the time we're done. That being said, I'm really happy and very proud, actually, to be sharing what we've been doing at York University. If you see me move around, I was told I'm not supposed to, but I can't stand behind a podium. It's not the way I do my presentation. So, as Stephen said, I teach foreign trained architects, and sort of in the first few courses, I teach materials and methods to them, and they rarely know what a vapor barrier is. In many cases, and they come from all over the world. And at the same time, one of the things I'm learning is that a lot of them are coming back with a lot of knowledge with regards to experience in BIM and BIM-related technologies. And it makes me wonder about what we're doing in Ontario, what we're doing in Canada, for that matter. Now, bear with me here just so I can give you a quick overview. This is what I'm going to talk about quickly. Like I said, 143 slides. I'm going to tell you a little bit about our team within the university. And there's two groups of ours. We're sister departments. Our department is made up of planners, architects, interior designers. We have 7 lead APs. Most people have been already introduced or are working in a BIM environment one way or the other, either for ourselves or with consultants or with others. We're doing some research with some colleagues at the university on the integration between GIS and BIM. This is what our department does. We do a number of things. We do about $15 to $20 million worth of work every year in terms of interior renovations. We also oversee the processes and delivery methods of those. This is the services we provide in-house within the university. And then some of these obviously are done with colleagues external to the university. Our sister team who works on the larger capital projects, like currently our $105 million engineering building, also known as the Bergeron Center for Engineering Excellence, which I'm going to culminate my presentation at this moment, this time period. That'll be the final project I'll be speaking about. And they oversee some very complex projects, and they are the facilitators. Our two groups, I would say, are the two groups that are basically between yourselves and the guy, Joe, with the hammer and the wrench. Okay, so we're the ones in between. Just quickly, I want to get some hands up. I know there's only 2 clients here, UTM and ourselves. Architects in the room? Architects in the room? Okay, there's a handful of you. Engineers? Look at that, architects. You guys got to invite more of your friends in. And facility managers? Okay, there's a few. There should be many more. Definitely contractors and builders. Oh my God, you must be with the owner somewhere else. Okay. Actually, part of the reason probably why there's a lot of absent owners right now, they're up in Thunder Bay. They chose that over Toronto. OAPA is the Ontario chapter of the Association for Physical Plan Administrators, which used to be called the American Physical Plan Administrators. And then there's ERAPA, which is the Eastern region, and I just want to put in a pitch. We're hosting with U of T next year the regional, so it'll be all the universities and colleges of the Eastern North America, so to speak. So we welcome you guys. I think the event's happening down here in downtown. For those of you who are not from the Toronto area, or you are, just to, let's see if this works. It says, okay, laser, here we go. That's the Sky Dome right there. We're roughly there. Our campus is about 22 kilometers north here. We have another campus where actually the university started over 55 years ago, where University of Toronto gave us their land for $1 or something like this. Goes the story. I think it's a myth. This is just some general statistics. We have basically York University's got about 873,000 square meters for our American friends in the room. That's 9.4 million square feet. We have 104 buildings, and there's over 55,000 students. We're almost faculty and staff. We're approximately 10,000 people in an area that's roughly, 185 hectares or 457 in the campus on Keele Street. So you can imagine we're like a mini city. And we keep growing. We have 2 subways under construction, which I'll speak about briefly, how we started at the university. That was actually, I'm going to go back. That's the guy on the right there is Murray Ross. There's a street around the university named after him. He was the first president with a vision. We believe that's in the middle of that field there, looking east, with a vision for a super university, which I think we are. Okay, so in 1967, these are some of the early buildings, pre-BIM. This is, I think, when they still did it on tablets, and they carved it in, they're the drawings, or I think it was a Mylar paper or something like that. And this is how Glendon still looks today, because there's been very little done to that campus, with exception of a recent addition that we did is a jewel on the campus there, which I'll show you in a minute. Fast forwarding some of our award-winning projects we've done on our campus, and I believe York's got a certain sort of, I would say, approach to design that really helps, I think, push the environment for our students and definitely our professors and our administration at the university. So all these projects, in one way or another, they've won some award or another, and I think we're going to continue that tradition going forward as we develop the future. At York, our recent project that we did at the university, a library renovation, a conversion of basically an ice rink into a world-class research facility, where we repurposed the wood to do steps and other things. The concrete was used to do an L-bar, all sorts of things. Some fabulous stuff. The jewel I mentioned at Glendon recently, which has won a number of awards already. And another project that I think was the start, really at a different scale in terms of the introduction of building information modeling. The skin and the structure was done that way. I wish more of the interior and the rest of it would have been done that way as well recently. This was part of the knowledge infrastructure development that we did. This is another knowledge infrastructure project. Also, in 2011, it was completed. It was about 200,000 square feet of renovations, got it down to the bottom, and we added about 25,000 square feet of new space for our Osgood Hall Law School, which is the oldest law society in Canada. It predates Canada. We also, in our department, oversee works by the late Roger Detroit of Detroit also Hillier, who recently passed away. This is some of their work that we're doing, so we oversee that. So many years ago, just to give you a little bit of background on myself, I was lucky and fortunate enough to live in the Washington area since 2004. I'm from Toronto, just in case you want to know. And I went to the U.S., and I was working there and noticed in 2005 and 6 that 50% of the projects being done that the firm I was at was already being done in integrated BIM. That's in 2006. It means architecture, structural, mechanical, and electrical. So knowing all that, when I returned to Toronto, I felt like I was a little bit in the dark ages. When especially I joined a university where things don't evolve very quickly. We are a big elephant and we move slow. And decisions are made because obviously we're using your money for those who contribute to us through the tax dollars. So we're very mindful of how much we spend, when we spend it, and where we spend it. And obviously this is the things that drives the universities to make decisions. So this graph basically shows that on the left, space heating, 51% of buildings the energy used is to heat buildings, 51%. So our university embarked on an initiative where we spent $45 million to save a lot more money than that. And we did an energy retrofit of our facilities across the entire university, and our payback was better than what was anticipated. It was supposed to be 7 years, and now it happens to be, it was actually in about 5.5, 6 years. And actually, MCW, who helped us with that, they're no longer at the university, just recently left. They finally completed their job, and we thank them for it. This is some statistics from the U.S. as part of the Architecture 2030 Challenge. Buildings use 48% of the energy that's available. 48%, that's almost 50%. Our buildings that we design today, we spend $50 million today, but it costs us maybe $200-300 million to manage over its life, right? So these are the changing drivers. This shows the embodied energy to maintain a facility over a period of time. You can see the number of years at the bottom. It increases, that initial capital investment, which is down here. It's, that was once, right? But it's never ending. So all these things, these are the drivers that I believe gave the impetus for us at York University to consider how we do our business. And we've been doing it a bit different. I recall when I first joined the university, everyone had an agenda because, they only had so many resources and finite dollars. So that means they couldn't stretch it to get innovative. And so everyone looked out for their little, box. And as you guys call it, or we call it, AKA silos. And that was the nature. So one of the things very early and very quickly with my team, we started to think about the end user who maintains the facilities, the guy who uses the hammer and that sort of thing. These are some statistics that shows you what's happened, and I think we've recognized it. I myself as an architect being on the other side, serving our clients at the time, these are the issues that I see owners recognize. 92% of owners say architects' drawings are insufficient. 72% of the U.S. energy is used by buildings. Division between design and the construction industry. And I think the one thing that I think that BIM, and maybe perhaps overlaid on top of that integrated project delivery has done, is brought us all together in some way or another. Because we have to collaborate, we have to share information, and I think that's bringing us together to actually think about the big picture from beginning to end, as opposed to, I'm the architect and engineer, we're going to design this for you, and off to the next project, and we're stuck with the building. Now that I'm on the other side, I recognize my own errors, I would say, and then my colleagues, so I try to enlighten my colleagues so that we do a much better job for the university going forward. And, you see some other statistics here. So traditional processes, traditional results, right? This is what's happened over time. And I noticed it at the university just recently where we were looking at a parking lot, trying to rush something for the Pan Am Games. And we discovered that the buildings and the trees and the road and the curbs all don't match, even though we've been keeping it up to date, so to speak. That's wild, So we had to do it on the fly. And I think we made it work, and we made some compromises. That's what we do. So, BIM at York. Why? You guys know why. This is the reasons why we felt it was important for us to consider. The important one is integrated design. That in itself meant that we're going to have basically information back to us that makes a lot of sense, that we can oversee and manage over a period of time. Because before it was disjointed, So objective data information, we can look at scenarios and test them very early if we could through the BIM process, which is something you can't do if you're working in a 2D environment. And so on. I mean, we were able to consider the impact on operations and maintenance. These are the reasons why we embarked on BIM. So these are some of our recent projects that we've done in some form of integrated BIM. We've done about 40,000, 4 very large interior renovations where we did interiors plus structure and or mechanical and electrical. And this is in a kind of a semi-warehouse office environment. It's our finance department. It's about $2.5 million that we did in a rush. Absolute rush. And if it wasn't for BIM, I don't think we would have done this successfully. So this was this is a small project, a key little project where this is where prospective parents and students would actually come and get greeted. This whole project was done in BIM. Mechanical, electrical, and architectural. Not as integrated as I would have liked it to be, but you know what? The fact that we were able to work out things along the process, it saves us a lot of trouble during the construction process. Again, coming back to this project, which I spoke about a little earlier, this is about 165,000 square feet, and it's $85 million total project cost. So, people always wonder, like, buildings, existing facilities, is that possible? Or here we go. We're using building information modeling, and the information that we learned from a major study, which I'm going to talk about in a second, is landscapes. So many of you who've been to the City of Toronto's City Hall, it's a podium. The buildings are sitting on a podium. There's another podium where the council chamber is. Ours is very similar. It's about 11,000 square meters, 120,000 square feet. And the entire design, landscape design, by Scott Torrance Landscape Architects is done in BIM, using also Civil 3D. And right now, we're implementing this first phase, which is part of a larger master plan and investigation that we did in this complex, which I'm going to speak about. Obviously, we're going to inherit the stadium files from the consortium through I/O. I'm not quite sure if we're going to be inheriting the BIM model itself. I'm not sure if that was contractually there. I know that the work was done to some effect using building information modeling. I'm hoping that we can in one way or the other. I think they owe us, to be honest with you, because they were late a year. So this is just some of the images of the facility. You're welcome to come to the games. They start in a few weeks, We're looking for a test event. You guys can run the track for us because we haven't done that test yet. We're working with Barrett, Sampson, Newark Architects on an expansion to the School of Business. It's about $40 million total cost, fully integrated BIM in this case, landscape, civil, mechanical, electrical, structural, etc. This is what it looks like. This is a site where we have a very complex site. And I want to point out all the constraints we have. An existing roadway that has to remain open, another roadway that has to remain open, an existing building has to remain functional. We have these two red lines is the new subway underneath. We can't be there, so the building is designed just on the edge, so we don't have to actually deal with the TTC. You guys have dealt with the TTC, right? Or you maybe missed your subway the other day when they closed down, right? So this facility is about 40 million. It's about 70,000 square feet, focused on graduate students, and it's got a solar chimney. It's been, that idea has been around for thousands of years, right, in the Middle East and other parts of the world. So just give you some more impressions of the building. And what's great about this, these interior, when we show these to our users, there's a plug-in, a cube, K-U-B-E, that allows you to do the JPEGs and do 360 in the room without doing any sophisticated work, right, like using some of the sophisticated technologies. And they love it. And this is our solar chimney that's due south. This is summer mode, winter mode. Now, I take you to the current. We're working with the students, and probably I have to say it's been invigorating working with students. They don't have agendas. They're not know-it-alls like a dean or a chair or somebody else on campus. They actually trust your opinion. Obviously, they'll question it because that's their job. They are the client. So we're building this approximately $70 million new student center. There'll be the second one on our campus. And this is being done in fully integrated BIM as well, mechanical, structural, landscape, civil, and the whole bit. And one of the things we did put out in the RFP process for this particular project right at the outset is that we will be evaluating the model along the way. And before we receive it, we would evaluate it before we actually transfer it to our hands for facilities management purposes. So it's going to be a beautiful building for the students. It's about 126,000 square feet, 4 levels, and it has some interesting spaces inside, including a convention center, which is probably one of the few convention centers on any student center, probably anywhere in Canada. And with it comes this incredible space up at the upper part, which is the multi-faith space. So if you've ever been to our university, it's very cosmopolitan. People from all over the world, so 54 different religious groups will use this multi-faith space. We currently use one now, but it's bursting at the seams. So all fully integrated. This is some views on the inside. I'm just looking at the time here. Landscapes to integrate it. So now I'm going to focus on 3 projects that got us started very slowly about 4 years ago. Something very, very, very small, and something very large existing, and something really fascinating that's happening on our campus that's going to change, I think, the face of this university for a long time. So our first case study. We began in 2004 when all of a sudden all the designers, planners, and coordinators in our department were actually working on various projects all in the same area of that red box. Okay? That's when we realized we had about $12 million of potential interior renovations, but we found out there's a leaky roof. So I realized very early that we had to fix the leak before we did the renovations. Otherwise, it would have been a waste. But in the past, this is how the university would have done it. One project after the other. No one was speaking to each other, the people who manage the facilities, the supervisors, the people on the ground, that sort of thing. So we looked at this facility, which is about 834,000 square feet, and we basically challenged, this is what it looks like in this winter, and this is what it looks like in the summer. The heat island effect is the same. So you'll be shivering or you're very hot up here. So we're changing the face of this place. We're actually going to give it life through a process that we started where we basically said to the consultant team, these are the 12 things we want you to look at. So I know in most instances a university or college would have actually hired 3 or 4 different consultants, and none of that information would have been integrated, right? So this is one team who did all of this. We explored all the scenarios, one after the other. It was three scenarios that ranged in total project opportunities, as we called it. But we looked at everything from space management, building performance, microclimate, you name it, and phasing and cost. So we picked a team happens to be from Chicago, and the names will be coming up. They did the raw model of our complex. Then they started to investigate the opportunities. Adrian Smith and Gordon Gill Architecture, they had recently done Masdar in Abu Dhabi and had done a sort of decarbonization of looking at existing buildings in the downtown loop of Chicago. So we knew that they knew what we wanted to do. It was quite obvious from their submission. There was no issue about, what happens to the model, this liability and all that other stuff that we always speak about, right? So that we looked at different options, investigations. Here is some scenario options, and in each of those options, then we looked at the energy, what the envelope was like, and the internal heating gains. But the raw base of that entire investigation was a BIM model and some other plugins that we did. So this is a proposed energy and carbon footprint for different options. You can see here. So the blue represents where we are. The red would be the new, and the green was where we want to be. That's how much reduction in carbon footprint or energy. This, again, I want to say, would not have been possible if it wasn't through a fully integrated BIM team. And we looked at and evaluated a whole series of initiatives and interventions, like you see here, from window shades to all sorts of things. Because we have these buildings that basically are facing west, where there's extreme solar gain, and we couldn't manage this. So this is, again, looking at one of the options in detail, lighting and so on. So what the outcomes of this study was, which was a one-year study, basically we looked at all these opportunities, and we were able to make some assessments and decisions as a result of that. And here in the modeling information, we were able to make decisions on where we're going to do the expansions, how water was going to be used, how we were going to reshape that roof, for example, and what kind of sustainable measures we would incorporate, that sort of thing. All of this came out of that BIM process, in that integrated process that we did. So this is just a summary, because this is a technology innovation kind of focused event. I figured you guys all want to know what the secret is, right? So there's the secret. There's nothing secret about it. But what's fascinating, we started, this is what the team used to look, and this is for an existing facility, okay? So Revit, MEP, there's Google Earth, there's Autodesk simulation. They also use some, the National Laboratory in the US for Systems Advisor for doing some renewables as well, investigations. And there's the various kind of for document preparation, all the sorts of things that they used. Moving forward, because I got 17 minutes and 38 seconds, case number 2. In parallel, so that was an existing facility. In parallel, we decided to try this in-house to test our folks, both from the executive level right down through our procurement division. So we embarked, and this is York Planning and Architectural Services, yes. We did it, designed it for ourselves, we fabricated it, and installed it for ourselves. We engaged no one. And there was a reason, but actually, I'll take that back in a second. We did, because you can't do this alone, right? So there was 2 locations that we were looking at, and basically, a professor had received CFI, Canada Innovation Fund, to basically do research on robots. So this is the guy who works with the OPP, RCMP, where he can actually test them all at the same time. But he needed these facilities in such a way that they can be closed when there's inclement weather, rain or snow. Also at the same time, he wanted to make, we designed it so that it's relocatable, because the land may be deemed for development at some future date, or the expansion of the storm pond. So we designed it, and I don't think Akshay is here, or Michael, who's an architect, and Akshay, who's an intern. Together, the 3 of us worked on this project. Among doing the design, we won an award for first place, an award for distinction from the MBI, which is the Mobile Building Institute in the United States. And what's fascinating about this little facility is that we gave it a dual purpose. In this case, it's a bus shelter. The model was given to the contractor, the fabricator, and then they basically used the model to do the shop drawings, the fabrication on site. And this is how it came to the site. It sits on basically 4 sonotubes. We can move it at any time. It's still intact. It's weatherproof, maybe not vandal-proof, because the glass was broken the other day, I think, by the students. They seem to always find a way to do these things, And this is the other location where the professor's, I think, pondering about, oh, I got to teach next semester. He's going, I think that's what he's wondering. So this is what we did in-house. Then we were able to basically take the procurement division through the process to get to work through the process, because we ended up selecting, in this case, NRB, which is right here, Niagara Relocatable Buildings, who do all the kiosks for gas stations and all that. This is their feature project now on their website, if you guys ever see it. And this has been featured as a supplement to the Canadian Architect a little while ago. And this is what they used it for, and that's how they brought it on site, and we were very excited about it. So, since I have 15 minutes, I'm going to go to the pièce de résistance because this is exciting for us and everyone at the university. So the Bergeron Center for Engineering Excellence, BCE, we're trying to figure out, we use a 3-letter acronym of buildings at the campus, so we're trying to figure out what we're going to drop here, the C or the E, I'm not sure. But when we put the RFP out very early in the process, we asked the entire consulting teams anywhere in the world to basically consider the following when they designed the building in terms of the integration of BIM. So everything on the left in terms of the integration from a design perspective. We had a BIM execution plan. We had a return on investment that Autodesk facilitated for us. It was a 4-day event where we basically talked through the challenges and where's the sweet spots when you work in BIM. And I don't know if you guys know this, but the AIA California has done a study already, and they've over 10 years, and they've done an analysis that there's a potential savings almost to 10%, definitely around over 5% on most projects in California if it's done in integrated BIM. That's just a statistic that you should know. On the right-hand side, what we considered the construction or the construction manager and the builders, what they should consider when they thought about building and developing and delivering this project in BIM. So they also used it for such applications as you see them here, from functional programming development, energy performance, hydrology. But most important, I think those 2 red lines at the bottom, their integration and collaboration. I think that was the key to any success of any project that anyone does, I believe. We embedded IPD principles. There's no contractual arrangement, so basically for collaboration and alliances of people, obviously harnessing people's talents, optimizing the project results, reducing waste, which is a big thing, and obviously where we can improve our efficiencies. And it resulted in the following, and I'm going to quickly go through some of these images and stop in some spots. This is the concept on a hill. This notion of a cloud floating over a hill. So that's the site that you see here. There's the pond, and there's the robotics pavilion that I showed a little earlier. There's the other one is up here. So that's one of the extreme west of the campus. This is what it looks like from a site design plan. Some incredible landscaping features there. When the skin was being investigated for the perimeter of the building, the envelope itself, you can see the scale of a person here. That gives you an idea what we were looking at. As we developed this, the pattern that you see there is called a Penrose pattern, which is developed by an engineer. And basically, it allows you to use 4 different triangles, and you can do infinite permutations of it. And our exterior facade basically uses about 80% of the panels are repeated. That's the efficiency that we have currently. And this is what it looks like. It's under construction right now. It will be open in September. You're all welcome to come. Not at the same time, please. But definitely, you're all welcome to come and see the facility. We would be happy to share with you. And it actually looks like this. It does really look like this. I'm absolutely flabbergasted by the team that both designed it, as well as the team has constructed it, Gillam Construction, with Langer O'Rourke from the UK, who teamed up to deliver this building. This will be the, obviously, a very special signage a sculpture for the person who contributed $10 million to our building. Now, this building's $105 million. It's 167,000 square feet, plus or minus 15,450 something square meters, something like that. It's 4 levels with a one below and one above for the penthouse. That's some of the interiors. And this is where we're going to create the new entrepreneurial engineer, the Renaissance engineer, where we flip the classrooms. So we don't have formal lectures here. They can do that online. They do it already, right? So here the idea is that they basically work together in a collaborative manner in groups, and it's project-based, basically. And that's what the dean wanted. I think that's what the university needed to do to differentiate themselves, basically, from all engineering schools in Canada. We couldn't just be another engineering school, so we had to be, obviously, different in order to compete. As a result, I think we supersede all the applications for engineering students of any university in Ontario by 30% because of the single building. This is some of the labs, some of the rooms, the project rooms for the students, other labs. So logistics, and we actually use this facility, the building information modeling process to manage the construction logistics. So the site trailer is here. And this is what happens inside here is I always keep calling it, it's our BIM command center, because LOR and Gillen, what they did is they basically introduced the subtrades to the model early at the outset of this project, so they knew exactly what they were going to be constructing over that period of time, whether it's that week, that month, and so on. And then they visualized and were able to know exactly what they were going to be building. So there's under construction. So it's real. And this is a rain screen system, by the way. It's got 175 millimeter Roxol insulation on the perimeter. This is the penthouse, some of the spaces. This is the backup of the exterior envelope. And you can see the backup system here. And I'm going to show you some other things that we did. This is under installation. It's about, I guess, a third of the way there for the exterior panels. And if you look carefully, the same triangles reappear. This is like about 4 of them. And it's the same with the glass and so on. So one thing I've learned, and I think we've all said, my AVP that I report to, I think our vice president, Lang O'Rourke, the architectural team, we have all concluded, with even having to do the analysis, that if it wasn't for building information modeling and fully integrated BIM being imposed on this project, there's no way this project would have been built in the time that we are building it in. There's no way. It just, because it's literally, it's been all in a sprint, and it's a very complex building. We're probably going to have one of the best civil labs in North America, I think, if you got the chance to see it. This is the backup wall for the exterior facade, which was basically designed using SolidWorks, in addition to Revit, in addition to a whole slew of things, Rhino, and for fabrication. And I'm going to share a little more with you in a second. I just want to show you some of these images. Under construction, the glass, we're one of the first buildings, I think, using the new bird-friendly guidelines, and hence the little triangles there. The as-built model. The as-built model that's being now developed by Lang O'Rourke team is basically probably combines in excess of 16 gigs, and it's made up of approximately 60 different models that makes up this model. You know, they've used it from everything you could imagine, from coordination, logistics, timing, takeoffs, you name it, you know, all sorts of things it's been used. The below surfaces were also mapped, everything. Sorry for the odd slide there, it's not focused. Also, basically just sharing the information of transposing basically the as-built construction information onto the design model, which was shared. And here's where, you know, the specialty trades like the ones fabricating the skin, the backup skin, created basically what they call, Lang O'Rourke calls these cassettes, which you're going to see in just a moment. So this is, we did a lot of off-site fabrication. That's what I said. It wouldn't have been possible if we didn't do this in fully integrated BIM. And here you are. These are the layers that make up the skin. Here's basically the cassette that takes the different patterns. Here's the shop drawings. Under construction in a factory, in a controlled environment, being put together. Also, we did plumbing, mechanical. There was components that were coming in flatbeds, basically, and they were put together like a jigsaw puzzle. And that's what I think saved us a lot of time. Oh, and also, I'm just going back here before I finish. Earlier, you guys, in the other sessions, you were talking about the folks with the wrench and with the hammer. So one of the things we've been doing for a little while now is we've been testing tablets through our maintenance group, because we want them to become acquainted with the use of a tablet. I mean, you can't basically expect them to use all the products that I heard this morning, a person who basically walks around with a tool belt, right? You just can't. So you got to acclimate them to the environment. So the first thing we're doing is letting them use tablets. That's how they get their work orders in Maximo. You know, have them pull it up, look at the information. So once they become very familiar with that, then we can actually have them access data such as the asset management information that we're putting into the model that we're going to use for facilities management. So it's a, you know, you got to take a small step before you jump, right? It's one of those things. So, and this was also difficult because the university didn't really have a proper asset management protocol. So we are developing on the fly almost in many, many ways. And as a result, because of this project, we are now embarking on a very formal process. If I showed you, I have a 2-page agenda for BIM at York that we now have every few months because we're moving it forward that much at the university. So this just shows you a summary of all the things that we did and used to do the design process. So here you can see for planning and architecture, the visualization, Navisworks, Rhino, Grasshopper, that's all part of what was used for the purpose of developing the skin. Obviously, CAT MEP with a plugin of bolt-on. I mean, it goes on. The suites, the number of software, SolidWorks for the backup system. I mean, and we also established the levels of development very early through our BIM execution plan. I think we're probably one of the only ones in Ontario. And if I'm wrong, please let me know. In terms of universities and colleges, that is. So I believe we're pushing the envelope. I mean, and then the fabricators and the construction team using such things as, these other HydroCAD, FatCAD, and so on, all sorts of things. And we're going to have an amazing building that you're all welcome to come and see. Thank you. So it looks like I got more time for questions than I thought I was going to have. I thought this was 4 minutes and then we were done. But
yep, you have 10 minutes. So if we have any questions, please come to the center podium.
Patrick, firstly, congratulations on the design of the robotics pavilion by the York University, which is
Thank you.
Very well designed. So I think your true success in what you've done at York is work with an institution to adopt BIM. What are the obstacles you encountered internally, and how did you overcome them for an institution to invest in BIM and adopt it as holistically as you have?
Yeah, I think it was definitely a lot more complicated than I thought when I first arrived at the university. I always say, people get when they hear I work at a university, and I thought working at a university would be an incredible experience. And don't get me wrong, it is. It's fascinating. That said, though, because we're like I described at the early start of the presentation, we're at 60,000, 65,000 people nestled in 457 acres. There's a lot going on. I mean, every minute of the day is different, and everybody has a responsibility in that. So it's hard to basically say to people, you have to do this way, when they've been accustomed to doing things in a certain way for 5, 10, 20, 30 years. I mean, I had people very early in the process when I arrived who basically invited me to meetings, private meetings, who wanted to share with me all the ills of the university. And I got all this stuff in my head. I think I need a couple of shrinks just to digest all that. But I heard them, and I never really put myself in that position when I was on the private side, doing something for a client. Now that I'm on this side, I recognize that I think introducing them very, very early to the discussion about how a facility is going to be developed is very, very paramount in my view. So when you can begin to conceptualize or think about what you're going to do, one of the things we tend to do very quickly, especially some of the smaller projects, is I get the zone supervisor who oversees the maintenance and operations guys, and we want to hear from them. How are they dealing with these other facilities? Well, we're planning to do a renovation over here. It's $5 million or what? No, 50,000. Tell me what the issues are in this area here. So they hear from you directly, not from their manager, supervisor, and downstream, because I think there's a disconnect. Like the broken telephone, it happens all the time. I think once you introduce them very early, they will buy into the process. So now people are finally, because we've been working on these other kinds of projects, it's not real buildings, people are finally come to understand that there is value in an integrated way of working at the university. Forget BIM, just working in an integrated way, right? Because someone impacts someone else downstream. So I think the challenge is always going to be the older folks who've been around for 20, 30 years, the lifers as they call them at the universities and colleges or hospitals, who basically have not been introduced to new technologies, new processes, new ways of doing things, new businesses. I think we don't invest enough on those folks. We invest so much more on research and teaching this and teaching that, and it's the folks who maintain these facilities and oversee them that have not received the funding to do the training to manage a world-class facility like this one. So for that very reason, we've embarked basically deliberately to begin a process to introduce everyone who will have a hammer and a wrench, what it means to have information readily available so that you don't have to go knock on that valve, turn that valve, look underneath here or there, but maybe they can actually pull it up in an iPad or in a tablet and look through some photographs that are being recorded. And that's the other thing we're doing. We're doing a photographic record that's going to be embedded to our BIM model, so our facilities folks can actually, at any given moment in the life of this building. They can go and see what was in that wall at a given time before it was constructed. So, any other questions?
Patrick, kudos to you guys to be leading this and participating. We did one project before BIM, fully in CAD, one project fully in BIM, and the transformation was great. 2 questions. You talked a lot about value. Does your procurement department yet recognize the value? Is that happening in the marketplace where you're seeing all the folks in this room do a lot more effort and bring that value to you as an owner? And is that being seen in fees and scope? And 2, once you have all this great information, what are you doing with it post-construction in the life cycle of the building?
Yeah, I guess with regards to your first question, procurement, it's we're lucky that the director of procurement services came from a construction company. So his experience 8 years in there understood what it is to procure material, product, and so on. So that in itself, I think, has been a godsend. So in many ways, it's really helped him and us to merge our thoughts. So they work with us. They very openly work with us. And I get sometimes more information or links or information or articles from our procurement department on BIM than me giving it to them. And that's the kind of environment that I think has been created. They allow us to basically incorporate whatever information regarding BIM into the documentation at a very early stage. This project was done in a 4-stage process, right? There's an RFSQ, which is a qualifications. We give everyone a template, you finish it, submit it down and dirty, easy. We select from that maybe somewhere between 5 and 7, depending on the nature of the project. Then we issue an RFP, detailed to everyone, very specific to BIM. In the RFSQ, we also did a little blurb on BIM. So at every stage, we're talking about BIM, 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 BIM. And so at the RFP stage, we describe what we want the outcome is, and we issue the BIM execution plan and what those outcomes will be for the purpose of facilities management. So we're starting to do that very early. And then in this particular project, we had a design competition where the 3 firms that were shortlisted all received a very handsome honorarium. I know other places don't do that. $55,000 each team got for basically 2 weeks of work. Because we wanted these people to understand that we meant business, that we were going to build a facility world-class, and every approach along the way had to be world-class. Hence why we're working with Laing O'Rourke from the UK and others from around North America. So that's hopefully answers the first question. The second question was related to what we're going to do with the data. So we're going to put it on a shelf like every other study, but in this case it's virtual, so it's not going to take up any space. I think that's a good thing. No, it's because of that Laing O'Rourke and our team, 2 or 3 of us, regularly have been meeting with Laing O'Rourke and the Gillam team, basically reviewing the model, getting acquainted with the model, making sure the right information is in the model for our purposes. Because earlier in one of the queries were, what information do you put in there? Because you can overdo it. And I think maybe now that I think about this, we probably were overdoing it. But I think we needed to do that to understand, where is our threshold, where the right sweet spot is. And I think probably it's going to take us maybe 2 more projects before we find that sweet spot. So the whole idea is now our maintenance folks, operations, to introduce them to the world of BIM, and the data that they wanted in the model is being inputted. So now we're going to develop protocols, as we call them at the university, SOPs, standard operating procedures for everything, right? How you transfer the data from here to there, how a renovation is going to be done, how the maintenance folk is going to read the information. So we're in the process of working on that right now. And that'll be the impetus, I think, for all our future projects, small or large, because we recognize that if we don't work in an integrated way, both within the university and with the extended team outside the university, then we're going to fail, and it's going to cost us a lot more downstream to manage these facilities, right? So.
George Economics, Bird Construction. Curiosity question. We keep on hearing about the IPD contract, and you've introduced the BIM IPD sort of process. So is there something that's hindering you to get to that next stage, or are you working up to that stage?
Yeah, that's a good question because, I think the idea and the principles, and when you're enthralled deep into your knees, your eyeballs in work, you know, some of those ideas, you know, harnessing people's talent, goes out the window a bit. But I think if you don't set it very early as a tone, then you might as well just forget about it, right? At least the fact that I know I have to exercise, it's conscious in my mind to remain healthy. I'm going to exercise at some future date. I was hoping to do it tonight, but I don't think it's going to happen. But, you know, the whole point is you got to put it out there. So we put it out there. We did the return on investment. And I think we would have done the new student center in that mode, but we couldn't do it because we have a different contractual arrangement with the students. The students have a whole different paradigm within the university. They're like basically the Vatican within York University, okay? So you can't really tell them what to do, and they kind of tell you what to do. Remember, there's 55,000 voices, right, versus our maybe measly 5,000 in Min. I mean, who are you going to listen to? So we recognized that it was going to be difficult. Maybe we're going to try it at a future project where we maybe consider doing the three-way agreement, because we know that that will be the next level of full integration. I know that. But you know what? One step at a time. I think it's important that, you know, we do small projects for existing buildings, small ones like we did the robotics pavilion. This is really a major, I think, aspirational project for everyone at the university, and for the, I think, engineering discipline at large in Canada, because I think students coming out of this facility are going to be a different engineer. I truly believe it. And I think great architecture supports, I think, missions and visions of universities. And so maybe we'll get there in the next project. We're hoping to do so. We'll see. Any other questions? Please.
Okay, last question, sorry.
Yes, I was wondering.
Let's see how quick he is, okay?
How would you match the accuracy of the as-built model compared to what was built on site?
How would I?
Yeah, in terms of percentage, what is the
Okay.
percentage of accuracy?
I'll give you a couple of answers. In my mind, it's perfect. Okay. In reality, it's probably not, and I know that for a fact because we've been watching it, seeing it. We meet every 2 weeks with the Langor BIM coordinator, who happens to be sitting here right now. It's been fabulous working with her, and so we become very. I think it's as accurate as it can get under the circumstances. I think when if you ask me the same question next year at a conference like this, after we've looked at the facility for a while, I probably have a better answer. But I think we're going to get pretty close to, you know, ideal to where we need it to be for the purpose of doing major renovations, facilities management, and so on. I think it's going to be as good as it's going to get, and probably better than any facility at any university. I'm saying that.
Okay.
I believe so.
Because I was wondering if we were using a robotic total station to match what the model has.
No, we haven't.
Okay.
No, we haven't.
Yeah, because we are dealing with this in a very narrow space ceiling that we're dealing with in a big hospital project in Trois-Rivières, Quebec.
And we may have to.
wondering if you know, the robotic total station has been used before in a facility, you know, a healthcare facility or.
And we may have to
facility.
do that in the future, you know,
Okay.
just to see really, you know, the way we see it, we spent millions of dollars in consulting fees. That's what our model is worth in our mind. You know, people have to remember the effort, you know, the challenges, the opportunities that it brings to the table, and that is worth a lot, not only in terms of information, but all the energy that was put into it. So we believe it's an incredible, powerful tool, and we'll continue to do more of those at the university. So.
Thank you.
Okay, I think our time's up. Thank you,
Okay.
Patrick.